Good morning, students. Today we are going to discuss about decision tree induction. So first of all, decision tree induction is the learning of decision trees from class labeled training tuples. Decision tree is nothing but it is learning of decision trees from class labeled training tuples. For example, here you might observing here there is one figure that is a decision tree for the concept Bayes computer. Bayes computer can act as a class labeled attribute here. They are given training data set Bayes computer. See, according to that, think you have a certain kinds of customer database. In that, we build like we are going to build this kind of particular tree here. Decision tree for the concept Bayes computer, indicating whether an all electronic customer is likely to purchase a computer. Here, according to that particular figure, age can act as a root node. Age can act as a root node. Each branch represents an outcome of the test. Here, whatever the branches we are observing here, those branches represents an outcome of the test, and each leaf node holds a class label values. Here, whatever the class label, class labeled attribute, that is Bayes computer contains a certain kinds of attribute values, like values, those are yes and no. Those are like here as I told that leaf node holds the class label. Then again remaining whatever the rectangle symbols we are observing in this figure, those nodes can act as internal nodes. Internal nodes denotes a test on an attribute. Here internal node can be used to represent or else denotes test on an particular attribute here. Okay, according to this particular figure, age can act as a root node. If age equals to youth, obviously your class Bayes computer says no. Again, if age equals to youth, again obviously the is student, then class Bayes computer equals to yes. And if age equals to middle aged, that S belongs to class Bayes computer, that says S. If age equals to senior and credit rating equals to fair, then class Bayes computer says no. If age equals to a senior and credit rating equals to excellent, then your class Bayes computer says yes. Like this, we are going to build a certain kinds of trees like based on training data tuples, whatever the content we have in that particular database. For example, database is nothing but it's a collection of interrelated information. Here that particular figure, all electronic customer is likely to purchase a computer. We are making decisions based on class labeled attributes. This is about decision tree induction with small example. Then algorithm for decision tree induction. See, initially during the late 1970s and early 1980s, J. Ross Quinlan, he was a researcher in machine learning. He developed this particular decision tree induction algorithm. This decision tree induction algorithm known as ID3. That is nothing but ID3 is nothing but iterative dichotomizer. Iterative dichotomizer. J. Ross Quinlan invented this decision tree induction. He developed this particular concept. See, according to that algorithm generate a decision tree from the training tuples of data partition D. We have, according to this particular algorithm, we need inputs data partition D, which is a set of training tuples and their associated class labels. Second one, attribute list. Obviously attribute list is nothing but it contains a set of attributes. Then attribute selection method. This attribute selection method it specifies heuristic procedure. It specifies heuristic procedure. Heuristic procedure is nothing but the thing it will going to discover itself. Without human intervention, it will going to find the things. Heuristic a procedure for selecting the attribute that best partitions the data tuples into individual classes. This criterion consists of a splitting attribute and possibly either a split point or splitting subset. This particular algorithm uses three things. First thing is D, second thing is attribute list, third thing is attribute selection method. As you all know that D is nothing but data partition. How the thing will go into partition means based on your particular training tuples on their associated class label. Then obviously second parameter is attribute list. Attribute list is nothing but it contains a set of attributes. Then attribute selection method, we have under that splitting attribute and then splitting a subset. With this particular thing, we are going to select the particular attributes. Here output, we are going to build a decision tree. First step says that first initially we are going to create a node n. That node n can act as a root for your particular tree. If tuples in D are all of the same class C, then return node n as leaf node labeled with the class C. What is this tuples? Tuples is nothing but rows and records. If tuples in D are all of the same class, then node n becomes a leaf node and it is labeled as labeled with class C. If attribute list is empty, then return node n as leaf node labeled with the majority class in D. These particular 3 and 4 and 5th step, if attribute list is empty, then return n as leaf node labeled with the majority class in D. This 4 and 5th steps, these two are terminating conditions step. If the things are empty, obviously there is no obviously, as I told that leaf node is nothing but does not have child nodes here. If attribute list is empty, obviously there is no need to move further here. Return n as a leaf node labeled with the majority class in D. Obviously, whatever the node we have, for example, according to that class based computer, obviously if we don't have any certain kinds of attributes in that particular given database, obviously we need to return n as a leaf node. Obviously that is a leaf node. Leaf node does not contain any childs for that. Leaf node labeled with the majority class in D. Apply attribute selection method according to this third step, according to input step. This is third step, apply attribute selection method that contains D, attribute list to find the best splitting criterion. Like as I told her, attribute selection method specifies a heuristic method. With that, it will go into select best splitting criterion. Label node n with splitting criterion. If splitting attribute is discrete valued, whatever the attribute we splitted based on that particular node, if that is discrete valued, then and multi-way splits allowed. If it is discrete valued, then multi-way splits allowed. Because if it is continuous value, there is no multi-way splits here. Multi-way splits allowed. Then attribute list minus splitting attribute. We are removing particular splitting attribute based on that particular attribute list here. For each outcome J of splitting criterion, partition the tuples and grow subtrees for each partition, whatever the partition we made with the help of a splitting criterion. Let Dj be the set of data tuples in D satisfying outcome J. If Dj is empty, then attach a leaf labeled with the majority class in D to node n. If Dj is empty, if that particular data tuple is empty, obviously just attach leaf labeled with majority class in D to the node n. Else attach the node returned by generate decision tree dj comma attribute list to node n. Once we done all these things, we need to end the for. Then again we need to return back to node n. This is about algorithm for decision tree induction. Then one more method here. According to that, like attribute selection based on decision tree induction algorithm. As I told that we have input. First thing is data partition D. Second thing is attribute list, and then third thing is attribute selection method. With this particular contains like this thing concentrates information gain and then Guinea index. See, information gain is nothing but we are concentrating certain kinds of attributes. Whatever the attribute have larger value, then that information can act as a information gain. Whatever the attribute we concentrated, we'll discuss later about how, with the help of problems, how we are going to gaining the information, how we are going to getting a larger value. With the help of a problem, we'll understand that. See, information gain have select the attribute with the highest information gain. Here, according to that thing, let Pi be the probability that an arbitrary tuple in D belongs to class Ci. Pi can act as a probability that an arbitrary tuple in D belongs to class Ci, estimated by Cid divided by D. See, here we have three things: expected information, then information gained. According to this thing, needed to classify a tuple in D. Info of D equals to minus summation of I equals to 1 to m Pi log 2 Pi. See, D is nothing but here data partition, as I told that, based on a training set of class labeled tuples. M is nothing but here that M can act as a distinct classes, like how many classes we made under that particular things given class labeled attributes. Then again here, as you know, that Pi is nothing but a probability that an arbitrary tuple in D belongs to class Ci. I is nothing but the how many classes we created in that particular based on given database things. Then again information needed after using A in here attribute to split D into V partitions. To classify D, info A, here A is nothing but whatever the attribute you are selecting while building this particular information gain. Info of A of D equals to sigma j equals to 1 to V dj by D into info of dj. Information gained by branching on attribute A. Gain of A equals to info D minus info A of D. This is about information gain. Remaining things we'll discuss tomorrow with the help of problems about this information gain. Thank you.